Hi, and welcome to the 10 square meter workshop. Today I shall be looking at making a table saw sled. Now, if you've spent any time at all on YouTube looking at woodworking videos, you'll be very familiar with these. There's an awful lot of designs with all sorts of gizmos and add-ons. But to me, they virtually all have one fatal flaw. This is a conventional sort of sled. It has runners underneath, which fit into the slots in your table saw. And it runs on those. You put the workpiece on the table, then slide it forward to make your cut. But there's one big fault. The surface of your table saw is metal. You may have invested a considerable sum in a table saw like this, with a cast iron top, ground flat and true. Even if it's not cast iron, it will still be pretty accurate. It's been designed to be flat and square, and the manufacturer went to a lot of trouble to ensure that. But with normal sleds, your workpiece is sitting on a piece of wood, which is in turn sitting on the table. Would you have bought your table saw if it had been made out of wood? I don't think so. Can this be solved? I believe it can. This is aluminium bar. It's 19mm by just under 10. That's 3/4 by 3/8 from the manufacturer, and it's a neat fit in the rails. This is pretty solid stuff, and cut in two with one going in each rail, it will be pretty substantial. This way the workpiece can sit on top of the table instead of on a piece of wood. In addition to the aluminium bars, I'll be using 4 thin aluminium packing pieces to ensure the rest of the sled is above the table. I don't want any scraping that might move anything. All the rest of the parts will be cut from this piece of 9mm ply. It's 300 by 800. This was cut into component parts on the table saw, along with some joining blocks out of 12mm ply from the scrap box. 2 of the longer pieces were glued together. And clamped to my router table, which I know to be flat. The 2 aluminium slide bars were cut and trimmed to 500mm each. To these will be joined the 2 cross pieces, front and back. Here I'm using the frame of the table saw as the guide to being square. I think we can trust it to be accurate, and of course the blade should be set to be parallel to the guide rails anyway, so that's our reference source. I shall be joining the parts together using 6mm bolts as shown, so I drilled 6mm holes in the cross pieces and laid it out, taking care to ensure that it's square to the table. I used a transfer punch to mark the rails. These were then drilled through 5mm. These were all then tapped out 6mm. With the parts so far assembled, I now have a nice sliding table. Time to build up the rest. Shaped and sanded, the 4 parts for the rear bridge look like this. And here it is, assembled, glued and pinned. The same type of construction goes into the main fence. Glued and pinned, and then sanded. The moment of truth comes after screwing it down. First of all, check for square, and I can't see any light through there. Now I'm going to check for squareness to the frame. I'm doing this with this pair of ground parallels. These are very precise. So I'll line up with one against the fence and see how easy it is to slide the other one down, and I can just feel a little bit of friction. Yep, just touching. That's about as accurate as I can get. I could of course adjust on the bolts if I needed to. I now have a sliding fence that moves smoothly and accurately, in which I don't lose any height. Maximum capacity is 325, which is fine. Any wider than that and I'd be cutting it on my track saw. The last job is to cut the blade slots, which I shall do in several passes. I now have a sled that moves smoothly in the track. I can't measure any side deflection at all, and the workpiece lies on the table, carried forward. I can of course add extra gizmos and blocks, but that's for the future. For the moment I'm pretty happy with it. And of course it has one additional feature. There's no reason why you can't tilt the blade. Having an extra slot in here is fine, and you haven't got a base plate to chew up. So, 3 advantages. Being able to cant the blade up to 45 degrees is why I put the extra rib in. That's where the blade will go. As a final step, I covered over the blade area. This adds both safety and strength. In operation, there's a clear cut line to work to. So here it is. A table saw sled that's no harder to make than a conventional one, but which has those 3 distinct advantages. That's all for this time. Why not subscribe so you won't miss anything? See you next time. Bye for now.